What's an anvil?
So I had the misfortune on Valentine's Day. I was about to have a nice dinner, and my brother calls me, and he says, "Hey, there's a tornado warning going on in my area. Can you try and find it?" So to prevent any of that from happening ever again and ruin my Five Guys dinner date, I'm going to explain to you the basics of weather radar. Now, this right here is the radar that's on top of the Oceanography and Meteorology building here on campus. Now, it's a ball. A radar does not have to be a ball. In fact, most radars tend to look like this. You have your antenna, and it transmits a radioactive beam to a cloud or other objects, and then it gets reflected back in the span of like a microsecond. It's extremely fast, extremely quick, and it shows up like little splotches like this. Now, obviously, it does not look like that. What we have on top of the Oceanography and Meteorology building is a fiberglass dome. Pretty much, the fiberglass is transparent to the radar, so it doesn't reflect and look like one concentrated spot on top of the building. It actually hits the clouds and the upper atmosphere. Now, we have a few types of radar. The most common one that y'all are most familiar with is reflectivity. Now, with reflectivity, it's measured in dBz. What dBz is decibels, and the Z is actually the reflectivity. This means that the measuring is exponential and not just like basic addition. So what that means is something that's at like 10 dBz, this blue stuff right here, is about 10 times weaker 10 times weaker than something in double strength, such as the green, which is about 20 dBz. So it's not double, but it's about 10 times. To get about doubling, that's about a 3 dBz difference. Now, what we have here is we have an extremely strong storm. Red is about, like this deep red right here is about like 50, 40 dBz. You won't start seeing anything purple until about 50. Purple is when you get hail, because those are really big. Now, what I mean by really big is the reflectivity is directly based on size. So this right here, those are extremely small water particles. This right here is heavy rain. Now, do note that radars are placed on high elevation or actually angled slightly up. Typically about 0.5 degrees, but they can be angled as high up as 90. But you really don't see 90, that's more of like the composition of the atmosphere. So the highest ones typically go about 4 degrees for basic weather patterns. This means that this actually isn't measuring precipitation, it's measuring the water based in the cloud. Now, what that means is, it doesn't necessarily mean that all of that is precipitating. Because it's red, you can pretty much assume it is, because the bigger the water droplets, the heavier are, and the more likely it's going to fall down. Now, what we have here is actually an example of snow. How can we tell that? Snow is actually weaker in general than rain when it shows up on radar. And you can also tell from this because everything looks kind of fuzzy. Yes, this may look pixelated, but it's more defined. It has designated pixels you can pick out, and you can see like it's generally correlated. This is all just like one big mess, and that's how you can tell. What we have over here, can anyone guess what this is?
Hurricane.
No, it's not a hurricane, but you can tell that it's... You're absolutely right. But mainly it's a tornado. You can tell because of the hook echo that's going on right here. So, to prevent y'all from calling me, if you see that, you know a tornado's going on and not ruin my dinner dates. However, there are other types of radar that meteorologists tend to use. So we have this one right here. This is not a reflectivity Christmas edition, but it is radial velocity. What we can tell from this is the direction in which the storm is moving. So you have your green and your red, and it's measured in knots. Knots are just a scientific way to say miles per hour. There's very little difference between miles per hour and knots. This gray line right here shows that it's moving perpendicular to the radar, so it has no relative velocity. So what this means is the green is going towards the radar, the red's going away from the radar. So that means the winds are moving the storm northeast, which most storms actually tend to move here in Texas. So if you ever need to look at a radar and don't know which direction it's going, just assume northeast, you'll be about 90%, right? Right here, we have correlation coefficient. This is, the best way I can explain it is like how correlated the rain is to each other. So this means all the precipitation around here is consistent, all the precipitation around here in the atmosphere is consistent, but this is getting a little fuzzy. We've got a little bit of mixing going on. Now, what I pointed out earlier is that the radar is typically angled up. So that means the further you go out from the radar, the higher up you go in the atmosphere. So right here in the atmosphere, we actually have ice or snow particles in the clouds. When it gets lower in the atmosphere and gets closer to the ground is typically warmer than up in the atmosphere. So the ice particles will start melting, and it'll be a mixture of ice, graupel, really big water droplets, and so all of that becomes not very correlated, and it becomes much different. So this is how you can tell that it's melting in the upper atmosphere, and it goes back down, and that's how you can tell it's rain, even without looking at radar, specifically reflectivity. Now you can actually get a second bright band. This is what it's called, a bright band. Closer if there is sleet, because sleet is refrozen snow, so that can get some pretty cool radar signatures. Obviously, most of the public doesn't know about these other types of radars, and you don't need to determine that if you want to determine weather. And this is where I do my shameless plug. And so if you ever need a weather forecast, you can always go to Tamu Weather on X/Twitter or Instagram. I do it every other Tuesday, so if you want to see me, if you don't, that's fine as well. But I do it every other Tuesday, so thank you.